Greetings, astronomy educators and advocates. I am Bill Waller, coming to you today from Rockport, Massachusetts in the United States. Here is my video poster for the daytime astronomy session, where I will describe how to reckon the Earth's size by taking a dip. So the big question is, how can you figure out the Earth's shape and size by still being on the Earth? And people have tried to do this over millennia, where at one point people thought that the Earth was a disk riding atop elephants, which were riding atop turtles, which were riding atop elephants, and elephants all the way down perhaps. But we've gone a little bit farther in our understanding since then. For one thing, we are pretty certain that the Earth is curved. You can tell that. I, living in New England, cannot see England itself, no matter how powerful a telescope I have. In principle, if the Earth was flat, you could do that. Instead, the Earth is curved so that there is a limiting horizon beyond which you cannot see anything else on the surface of the Earth. Armed with that knowledge, Eratosthenes, way back in 250 BC, he worked out a way to determine the circumference of Earth. And there he noted that in Syene on the summer solstice at noon, that the sun was at the zenith. It shone straight down, illuminating the bottom of a well. By contrast, some distance away in Alexandria to the north, the sun did not make an angle at the zenith. Instead, it made an angle that was 1/50th of a circle from the zenith. And so he inferred that by multiplying this distance by 50, he would be able to get the circumference of the Earth. And based on what the unit of a stadium is, it seems like he got pretty close to the mark. One could do it today. You wouldn't have to wait for a solstice. You could do it at any time of day. But you'd have to use a cell phone and call somebody directly north or south of you on the Earth, and knowing the distance to that other place. Here for me in the Boston area, I would call somebody in Quebec City, which is around 400 miles away, and we would measure the angle of the sun and compare the angles, take the difference, and that angle would be able to be used, and the distance, to determine the circumference of the Earth. But I wanted something which I could do by myself without referring to anybody else far away. And it turns out that from my home, there's a beach called Front Beach in Rockport, Massachusetts, and I can sight from that beach a part of a breakwater, which was built back in the turn of the 20th century. And knowing the distance to that piece of rock on the breakwater, which is just near the surface of the water, I could walk in and walk down. Using binoculars, I could sight that piece of rock and see the point where it started to submerge, fall below the horizon. And by measuring the height of my eyes from the waterline, I could derive geometrically the radius of Earth. The geometry is pretty simple. Here's Earth, assumed to be a sphere with its radius, and my height above the waterline, and the distance to the object on my local horizon. You basically have a right triangle, and you can use the Pythagorean theorem to derive the radius of Earth. And the results have been pretty darn good. I've been doing it with students, high school students, for several years now, and we typically get results which are accurate to within about 10% or less. And so I invite you and welcome you and encourage you to try it yourself. If you happen to have a beach nearby with something in the background near the horizon, like this breakwater, and you go in and you get to the point where you can no longer see that, and then you measure the height of your eyes to the water line there. Similar experiments can be done in the desert, other flat places. with objects which could be placed at the horizon or found near the personal horizon. So if you're interested to pursue this, you could go to Dr. Waller's Science Gazette and find videos which were taken during a particularly choppy time on the water. So thank you very much.